So this is a different version of this question. It's actually one from the post office rather than some random set of numbers. And what's different about, well, the one I looked at in my open math, this had 98 instead of 108. So maybe you'll get a problem with 108. Maybe you'll get one that's a little different. But you can solve these all the same way. And so what they say is, it's the girth. So they can't the maximum dimensions that they'll accept, whether it's the post office or whatever company, is that the girth, which is this distance, those four sides, plus the length of the package, can't be any more than 108. I guess that yellow doesn't show up too well. So what you got to do is, as you see how I labeled this here, I labeled that as x by x by y long. It's kind of where the Mountain Math is leading you anyways. So um, I thought I'd do it this way. So I know that y, so for this variation of this problem, I know that y plus 4x, because there's four sides of square, it's a square end, so each of those sides are 4 long, so we're basically looking for the perimeter. So it has to be 108. It has to be no more than 108. So I said, well, I don't want to do an inequality. I said, let's set it equal to 108. That way we'll find the maximum value. And then solve it for y. So then the method is solve that equation for y or x, whichever one's easier. Well, for me, I think this way solving for y makes a lot more sense. And then what we want to maximize, and this is one of the steps in these optimization problems, is what are we trying to maximize? We're trying to maximize the volume in this case. So volume equals the area of the base times the height. Well, the base is a square, so x squared times y. So that's the volume, and that's what we want to maximize. So um, I don't want to have x's and y's in my equation. I want to avoid implicit differentiation if I can. So, and it's not a related rate question, it's an optimization question. So we want to try to work with one variable if we can. Um, Calc 2, Calc 3, you might be doing two variable optimizations, but we're not there yet. So I'm going to replace y in this volume equation by the 108 minus 4x, and then I distributed the x squared through. Now I'm going to do the derivative. So power function, I'm going to use a power rule. And then I notice I can factor out a 12x. And that left 18 minus x. And then I probably should. I mean, I know 0 is not going to be the maximum, but I do. So probably 18 is going to be. But we got to verify it, make sure. Okay. Um, so one of the questions they ask us in MyOpenMath is, what's the domain we could use? Well, if the end is 0, if I don't have any end, all the 108 has to go into length. And if there's no length, all the 108 has to go around that girth. So 108 divided by 4 is 27. So the domain is 0 to 27. Now, I said open intervals because we aren't going to use one that's 0 on the end or 0 on the length. So it's kind of crazy to include those. So, but what that helped me do was give me some places, at least something to mark off. So something I didn't write on my paper is this is actually f of x, right? I'm trying to work with f prime of x is what this number line represents. I'm trying to look to see when is the function increasing, when is the function decreasing. So then I marked 0 is one of the endpoints, and 27 is the other endpoint, and 18 is the other critical value. So then I took a number between 0 and 18. Actually, I picked 1. Well, if I picked 1, that's positive. 18 minus 1 is positive, so positive times a positive is positive. And then if I picked a number bigger than 18, like 19 for that matter, that the 12 times 19 is okay, but 18 minus 19 is negative number, so the derivative is negative. So the function's increasing up till 18, then it's decreasing. So we're looking for the maximum value. So when the x is 18 by 18, well, when this is 18, so the dimensions are 18 by 18 by the length. Well, how do I get the length? Well, if I know if there's 4, I know y equals 108 minus 4x. So 108 minus 4 times 18 works out to be 36. So that's the maximum dimensions. That's the dimensions that will give us the largest volume. Now, MyOpenMath doesn't ask us for the largest volume, but that's how I would get it, right? I'd go back to that original volume equation and do that. So hopefully this helps you solve your version of this question. Okay, so this is a pretty classic problem right here. This is number 21. And before I get into it, in case you're interested, you get some time, you feel like reading about math and reading about teaching and people overcoming obstacles. Jaime Escalante was a Bolivian math teacher who came to the States and started teaching in the States. I'm really making a short story. Um, Jay Matthews is a reporter for the Washington Post, and he wrote this book about him, which got made into this movie, which came out in '88. Good movie. If you don't have time to read the book, watch a movie. What happened is one year. The reason I'm pointing this out for this question is uh, once things started cooking at the school and students were starting to be very successful with calculus. Um, one year the tests usually get mixed up. The AP tests get mixed up pretty well so that no one reader sees more than one student's work from any one school. And that year that didn't happen, and one reader saw three or four pieces of work from that school. They score one problem is what you do. So that person got assigned this problem, so he was scoring all the exams with that problem, and well, spread the load out. And the kids from that school that they looked at had all the same incorrect work for this problem. They'd done exactly the same way, so they accused him of cheating and so on and so forth. I won't spoil it for you, but that's what happened. That's why, like, when I do this problem, I always bring this up. Um, so, anyways, how do you do this problem? Enough for the math history lesson, the math teaching list history lesson. So we've got a box. We've got an open top box. We don't need a top. So that box looks something like this, doesn't it? Let's see, we've got it's a rectangular base. So let's draw a rectangular base. I'm doing a lousy job drawing this today. All right. And then, so normally I would call this L, W, and H. And we know that L times W times H is the volume of a rectangular prism. And they're telling us that that rectangular prism is supposed to have a volume of 1024. So we're going to hold that thought. I'm not going to do too much more with the L, W, and H, just so I don't mess things up here. Now, what's going on here is we've got it tells us the length of the base here. Where's the pointer? The length of the base is twice the width of the base. So instead of doing L and W, I'm going to call this X. Here, let me do some erasing. We're going to call that X, and we're going to call this 2X. This is twice as big. So now I've only got two variables. It'd be nice, but really I've got three because of the volume. So I'd be nice to get rid of the H at least. And I know the volume for this box has to be 1024. So I know that 2x squared times h has to be 1024. So doesn't h have to be equal to 512 divided by x squared? So we'll hold that thought here. That will help us. So this is let me let me erase that? No, it's already gone. I can't do that. Can I delete it? I probably delete the whole thing. Well, okay. No, let me see. Well, here. I'll just redraw it here. Give me a second. I'll redraw it with the new dimensions. Okay, so this is 2x, this is x, this is 512 over x squared. Okay, so what's the cost of the base? Well, they told us the cost of the base is 12 bucks per square foot. So the base, we only need the base, we don't need the top. So that base has an area of 2x squared. And then, of course, we're going to multiply it by the cost per square foot, which is 12. So 12 times 2 is 24x squared. That's where I got that from. Okay? Now it wants us to find the sides. So let me do some erasing here. So I've got two different shaped sides. I've got one that's x by width times height, right? So x times 512 over x squared. And of course, there's two of them because there's one on this side, right, and one over here. And then that cost is $8. So that becomes, and what happens here, so you see where I got the 24x squared from, right? Now, the 881.92 is coming from this. 816 times 512 is 892. And then, of course, I've got an x here, and an x squared here cancels out. So that's where I got that term from. So now, where do you think I got the other term from? Knowing that I've only have, what, two sides left. Whoops, I don't want to undo that here. Don't I only have this side and this side? Can you figure out what that area is? I mean, you can always stop it and come back, or if you just want to watch it, just watch it. So I know I've got, this is 2x by 512 over x squared, and there's two of them, and each of those sides cost $8, or $8 per square foot. So the x's, again, the x's, one of those x's cancels, right? That x cancels one of those x's. And when I do 8 times 2, 8 times 2 times 2 times 512, I'm getting that 16,384 over x. So that's the total cost for the three sides. Now, of course, we're going to take the derivative of this. So how did I do that? Well, what I did, the thing that I didn't do, that now that I'm looking at my work, I might have done this. It would have made my work just a tad easier. Is that these really are like terms. I could have added those two numbers together and put it over x because they're like denominators, right? They have the same x, so I could just add them, and I would have only had two terms to deal with rather than three. But my upper math didn't care. So now let me make some space here. And we'll take a derivative. I'll show you how I got that derivative. So the first part, I just brought the 2 down in front, right? And that's where I got the, 2 times 24 is 48, and I subtracted 1. And then for these other ones, I'm hoping you're getting to the point where you know that I can rewrite the 8192 over x as to the negative x, and then bring the negative down, subtract another negative, which becomes x squared on the bottom. And then I did the same thing with the other one. So that's what I did. And again, I could have put those together to make one. So then I got to find, where does the derivative equal 0? Well, so I'm going to take that derivative and solve it. Now, the fractions are driving me nuts. So what I want to do, there's x squared in the denominator, so I'm going to solve this thing for 0. So what I'm going to do is make it all be one fraction by multiplying everything by x squared. Get common denominators. That gives me 48x cubed minus 8192 minus 16,384. I see why it would be easier to have that just be one term all over x squared. Now, the denominator doesn't care. I don't care about, because really all I want to know is when this numerator equals 0. The denominator can't be 0, so what I did is 40, I combined some like terms, 48x cubed minus, what did I get? Did I write that number down? Yeah, 24,576. Where does that equal 0? So then I move this over, divided by 48. That left me a nice 512 equals x cubed. You take the cube root of that, x equals 8. So that was the critical value. Okay, and then they wanted us to test the to see if it was a minimum or maximum. They suggested doing the second derivative for that. So if I take the derivative of what did I do here? I know what I did. I at this point I added those two terms together. Okay, and that's where I got the 49 153 from. And then I broke it back out to see how it became x. Well, you can't see that. You can't see on my paper. I'll submit it here. I don't want to delete that. Can I delete that? No, I'm gonna lose the whole thing if I do that. If this is all over x squared, can't I break this out to 48x cubed over x squared minus that 24,576 over x squared? And then the x squared and the x to the first. So that way, what's the derivative of 48x? Well, that's just 48. Here, let me come back and erase this. Come on, will you let me erase it? No, I guess, can I delete it? Yeah. And then I just use the power rule again. Brought x to the -2. Negative times a negative is a positive, and of course it doubles it. Doubles the 24,576 over, and then take away 3. And then I just grabbed my calculator and substituted in 8 for the last part. So 48 plus that 49,152 over 8 cubed, which is 512. That worked out to be, oh, what did I get? Did I write it down? Oh, but I wrote it there, 144. And because that's positive, it's too bad they made us actually evaluate that, but that's okay. We know it's positive. That means the function is concave up. That means that at 8, that's a minimum. Okay, so that's the process. Hopefully you can do this. I mean, you'll probably get a different values. I bet you that 1024 is a randomized number.